So think of you go out every day and click a picture of a sun from exactly the same position for an entire year, and if you overlay this all every single day image 1/1 to build a single image, how the sun position pattern will look like in the sky, and you will notice an exciting sun movement in the sky throughout the year. So this shape the sun will form is the analemma curve.
Namaste Sai fam and welcome back to Sai with CS. So today we will look how does the analemma curve is formed by the sun on the sky and why it has its particular 8 figure shape. Okay, so before we proceed further, I think we should know what is the use of analemma curve. So well guys, what if I tell you you can predict the sun's position, that means where will be the sun on the sky for any given location for any given time. You can predict the sun position using the analemma curve. We don't use actually the analemma curve as it is formed by the sun on the sky, but we do a little modification with it and we plot this curve on the graph, and we use this curve to predict the sun's position on the sky. That means you can tell where will be the sun on the sky. Suppose for the 5th of April, where will be the sun in India or in South Africa or anywhere else on the planet. You can tell the sun position for any given time also. So that's how cool it is the analemma curve is. So with the help of the coolest experiment that we are going to do to understand how does this analemma curve is getting formed and why it has the particular figure shape. So let's get started. So as you can see, it's a 152 million kilometer on the longer radius and 147 kilometer on the short radius. So this what makes Earth orbit ellipse. I have divided this orbit into the 12 months and it gives the respective seasons as solstice and equinoxes too. So as you can see here, in July, in the 4th of July, the Earth is in its aphelion. That means this is the farthest from the sun on the 4th of July. So when the Earth is here on the 4th of July, the Earth is the longest distance from the sun, and when it travels to this from July to the September, on the 23rd of September we achieve the September equinox. So that something gives the 12 hours of day on the whole globe. Okay, so that is something we call the equinox. If you didn't have my video on the equinox, you tap over here on the I button, you will know in detail equinoxes and solstices. December, on the 21st December we achieve the winter solstice, on which the northern hemisphere is away from the sun, tilted due to Earth's axial tilt, which we look after in a detail. So on the January 3rd we achieve the globe, Earthians achieve the perihelion, and Earth has the closest approach on the 3rd of January. Sun is really closest to the Earth on the 3rd of January. Sun is getting more closer to the Earth. Gravity affects the speed of Earth in a rotation around the sun. Okay, so Earth travels faster in this region than this one because sun is away from this side and closer to this, so gravity affects. So then we achieve the March equinox. So March equinox, they repeat the same concept, and then we achieve this June 21st. That is the summer solstice, exactly opposite to the December winter solstice. So now here the northern hemisphere here is more closer to the sun, so we achieve the summer here due to the closer approach to the sun. So as you know, the Earth has the 23.45 degree axial tilt, and Earth also rotates around itself and the rotates around this orbital plane too. So this is the things that gives an analemma curve its particular figure 8 shape curve. So let's understand this all within a detail with the help of this green ball, so which we are going to use as the Earth. So let's get started. These lines are the latitude lines. So this line you can see which cutting the Earth in two halves. So this is the equator line on the 0 degree north, and the upper latitude line on the north side on the 23.5 degree latitude, this is the Tropic of Cancer we say, and this is the Arctic Circle on the 66.5 degrees north, and this is the North Pole. Okay, this is the Arctic Circle. So above the equator, towards the north, this is the northern hemisphere, and down the equator towards the south pole, this is south pole, this is the southern hemisphere. Okay, so on the 23.5 degrees south, this is the Tropic of Capricorn, and the Antarctic Circle is on the 66.5 degrees south. Okay, so clear. And this is the somewhat I have drawn as the India map. And suppose you are living over here, so we are going to draw the analemma curve for this region. Okay, so we are going to draw an analemma curve for person living over here. Okay, so how he or she will see an analemma curve. So we are going to draw the same. So this is the India, as you know, India lies on the northern hemisphere. So we are going to draw the analemma curve.
This is a sun that we are going to use. The Earth rotates, but as we are going to use this laser pointer, so I would have to move this around along with the Earth. So at the very first, on the June 21st, summer solstice, sun is exactly over here, and it has get tilted the northern hemisphere towards the sun on the summer solstice on the 21st June, and Earth rotates around itself too, like this, with this axial tilt. Okay, so when does the analemma chart form? As I earlier said, that when you capture the image of a sun from the exactly same time, from the exactly same location. Okay, so as you are here, Earth has tilted towards the sun on the summer solstice. So we are going to mark the first position of sun here. So suppose you are standing over here and click one photograph of sun. So I'm here, as you can see over here. This is the sun position. So you rotate. Like this, and next day arrives, and Earth also rotates around this position. So you get a little over here, and when the second day arrives, and at the same position, at the same time, you are going to click the second picture of sun, and we are going to mark this same point over here. Okay, so this is how you. So Earth rotates like this, and you go over here. Okay, and sun is still there. So you are going to click the same picture of the sun on this. Okay, so you rotate like this one. Sun is still there, but you are not going to take a photograph when you are here. So you once head in this same position, you come. When you head in this position, at the same time you are going to click the second picture of sun. Similarly for this positions also. So rotate like this one along with this two, and when you arrive on the equinox, on the equinox, the actual tilt is like September solstice. So you are going to mark same positions and points. So on this solstice, you arrive over here. Our heads toward on the winter solstice, Earth axis has tilted like this one, away from the sun. Okay, so that's why we face the winter, and we position the marked position over here. Okay, on the winter solstice, on the November and December. So after going to this, within this area, Earth travels really faster than the other, due to the sun is more closer to this, and the sun is more closer to the Earth. The gravity results in a faster speed of Earth revolutionary speed. So you mark the positions over here. Okay, so after this, January, February, and March, the Earth goes to this on the March equinox. The same concept here for the March. So these are the two equinoxes exactly opposite to each other.
So Earth, as you can see, the broader area of this analemma curve here is the broader, because Earth travels more faster in a January from this position to this, and exactly opposite on the other side here, Earth travels more slowly because it's away from the sun. So there is the little side on the top side, on the north side. Okay, so these are the equinoxes, and the solstices are upside down. So that's why an analemma has its particular shape of figure 8. So this is the analemma curve that we have made on the earth ball over here in the experiment. So for our convenience, they have plotted this curve on more sophistically on the paper over here, on the graph paper over here, as you can see. So just to tell you in a brief about this chart, these lines are the latitude lines of sun declination. Here is the south pole, as you can see, south, and here is the north pole. Okay, so these are the tropic of Capricorn and the tropic of Cancer over here, the two lines, and between this all the subsolar points will fall. Okay, so the declination of sun is basically means that the sun is over your head. Okay, for this particular latitude, over your head, that means the sun rays are vertical to your head, and that means your shadow will fall just under your feet. Okay, so the shadow will not appear on the declination of sun because the sun rays are vertical, sun is vertical. So to check it out and verify this chart, as you can see, I will tell you here, so you can check it out for the verify. As you know, on the December and the June, like equinoxes and solstices, you know the solar declination, where will be the sun declination. Okay, so just we will check it out on this chart. As you can see over here, on the 21st of December, you know where will be the sun declination, as on the tropic of Capricorn. Okay, so just check it out on the 21st of December. Here I will put a scale over here, and you can check it out over here, sun declination. Okay, so it's between the 22 and 24, and here is the 23 line. Okay, so it's around the sun declination is about the 23.5 degrees, and just you can also check it out for the equinox. Okay, so let's check it out for the March equinox. So as you all know, the sun declination, the sun is vertical at the equator on these equinoxes. So for the 21st of a March or the 20th of a March, so this is 20th March or 21st March, sun declination, you can check it out just putting a scale horizontal, and you can check it out, it's around the about 0 degrees. Okay, so it's the sun declination is at the exactly at the equator. So this is how you can find out the solar declinations for subsolar points using this analemma curve. So looking into the more detail, the equinoxes and the solar declinations for your particular location, I will post a dedicated video in detail on this chart. So if you like this video, please hit the subscribe button below and like this video.